Today we're looking at T&D, or test and development as we call it. This is where we do all of our big mechanical testing. So we focus on reliability, so making sure that the components will last properly and they'll withstand the forces that the car sees. And we also do some work on performance. So looking at things like suspension and damper settings, making sure that we're getting the maximum performance from the suspension as we possibly can. What you can see in this room is actually only a small set of what we test. All of the side rooms contain bespoke rigs of their own. So you have rigs for looking at suspension, we have rigs that look at braking systems, rigs for looking at power steering. We also have rigs for things that are not on the car, so things like wheel guns, for instance, will be tested in here, because obviously it's really important that they're reliable as well in a pit stop. So the work in this department is it's not seasonal because we work all year round, but the structure of the work changes during the year. So before the season, most of the work is about making sure that the parts are strong enough that they're going to survive the racing. We do work with the FIA to make sure that the chassis will survive and will protect the driver if we have a big crash. And then as we get into the season, the work shifts from testing new developments and also to things like making sure that the components that come back from the racetrack, proof tested and fatigue tested to make sure that they're still fit for purpose. Because we obviously need to make sure that we get the best performance out of the car all year round and it's reliable all year round. As you can see, there's big machines around in here. There's high-powered hydraulics capable of shifting actuators that can move 100 kilonewtons, so 10 tons of weight, so huge forces. So before you come in here, you have to be inducted into the health and safety. You have to be shown what's safe and what's not safe. The rigs themselves are completely safe to the operators because they're highly trained to use these facilities. But for anybody that doesn't know what they're doing, there's obviously quite a lot of dangers. This is a 7-post rig, so-called 7-post rig because it's got 7 actuators. It's got one under each of the wheels and 3 vertical actuators that model the aerodynamic load. So there's no lateral loads going on here, this is just purely vertical. And what we use this rig for is looking at damper settings, looking at our suspension settings, trying to work out how we optimise the ride of the car. So what I mean by ride is if you imagine the car's going around a corner and it's got the aerodynamic load on it and it hits a curb, what we want to happen is after it's hit the curb, we want the car to settle as quickly as possible. Because if the car is bouncing, we're not getting the full grip that we could be getting from that aerodynamic load. So the way we tune our dampers, the way we tune our springs is really important, and that work happens here. And that work is done in conjunction with the work we do in simulation. What we've got here are the two 12-axis testing machines. So this one for the front of the car and this one for the back of the car. These machines are there to sort of test the car structurally. So when you look at these machines, the actuators here, they're capable of delivering about 4 tons of force. The big actuators we use to apply vertical load, they can go up to 8 tons of force. The reason we call them 12-axis machines is because actually they apply the 6 degrees of freedom, so the 3 forces and the 3 moments that we've got on each of the 2 wheels. So the sort of things we're trying to do with this machine is play back the conditions we've got on the track. We're not only trying to get the sort of steady state loads, but we're also trying to get all the vibration loads, the things that happen when we hit the curbs. These machines can play back those forces very quickly. In fact, we can gather about 2,000 kilometres worth of mileage in an hour. So much, much quicker than we can do at the track. And what's really amazing to think about is when you think that these forces are just coming from the tyres. So the tyres may have a contact patch on the ground that's sort of this sort of size, and that friction on the ground is enough to put these sort of forces through that are bending the gearboxes and bending the suspension is crazy, really. And then when you look at how that force is then transferred through the tyre through a very narrow sidewall and a chunk of air, it's pretty impressive what the tyres can do. The sort of conditions we're trying to match, it's not only the normal conditions we see, we also need to encounter or test for the conditions that are going to be really unusual, like a car going backwards or hitting the really heavy curbs that we wouldn't normally hit. These machines are really, really important to us. Without them, we couldn't prove out all the suspension in one go, all of the uprights in one go. So they're key bits of our equipment, really. These are our Instron test machines. So you can see we have an array of them. And what we use these for is sort of single axis testing. So on the 12-axis machine, we're able to test the whole of the suspension together. So either the whole rear or the whole front. On these machines, we're only testing a single axis. So we're able to look at one individual component and look at how that will perform, both in terms of its ultimate strength, but also in terms of fatigue loading. We're also able to put ovens around these machines and look at what happens to the fatigue life of components when we heat them up. So some things we'll test are maybe track rods, heave spring units, things like that. So things that we test in one single axis. The sort of capabilities of these machines are roughly 100 kilonewtons or 10 tons, so pretty powerful machines. So the next step on our tour is the gimbal rig. So we use this for testing the gearbox primarily. And what we're trying to do with this rig is to simulate the sort of things that happen in a corner and also in accelerating and braking. So as the car goes around the track, the oil in the gearbox is moved around by those G-forces. And what we don't want to happen is for the gearbox to be starved of oil in any particular place, because that would potentially lead to failure. The sort of simulation we're doing is we can move the gearbox to simulate that sort of steady state G-load, longitudinal, so braking and accelerating. The other thing we can do is we can test different lubricants in here, for instance. So we work with our partners Petronas. They obviously provide our fuels and lubricants that we use. So we can obviously do quite a bit of testing with them in here as well.